Hello everyone, welcome to another video on object-oriented programming with C++. In the last video, we saw what is encapsulation. Especially, we talked about this protected access specifier, and then we talked about the different modes of inheritance. Right? More specifically, we talked about inheritance access control. Right? In this video, we are going to look at types of inheritance, and then I'm going to end this video by talking about some of the disadvantages that they exist in inheritance with inheritance, and then I am going to give a brief overview of how to uh, get over this disadvantage, how to remove these disadvantages. So without further ado, let us begin today's video. So what are the types of inheritance? There are 5 different types of inheritance, right? They are single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, and hybrid inheritance. Let us go ahead and look at each of them uh, with examples. So the first thing that we are going to look at, it is going to be very easy. We have this class called animal, and from that we inherit and we create a class called mammal. Right? We have this class animal and we have this class mammal, and mammal inherits from animal. Alright, this is known as single inheritance. So there is a single base class and a single derived class. The derived class inherits from the base class. Alright, very simple, straightforward. There is nothing to explain over here. So I'm not going to waste time trying to explain anything. Let's move ahead and look at the next example. This is multi-level inheritance. Here, once again, I have this animal class. Alright. Then from this animal class, I have this class called mammal that inherits from the animal class. Right, and then from this mammal class, I have this class called cat that inherits from the mammal class. So now I have multiple level of inheritance. Previously, I had only one level. So there was this derived class, this mammal class that inherited from the animal class. So there was a single level. Okay, it was single inheritance. Now we are looking at multi-level inheritance. Here we have two level. This mammal inherits from animal and cat inherits from mammal. Right. We have seen codes like this where there are multiple inheritance. We have seen this example itself in details. I have this class called animal. I have this class called mammal. This mammal class inherits from animal, and I have this class called cat. The cat class inherits from mammal. Alright. So this is multi-level inheritance with two different levels. Once again, let us look at more multi-level inheritance. Okay, this is a multi-level inheritance with 3 levels. So I have this animal, this mammal inherits from animal, cat inherits from mammal, and Persian cat inherits from cat. So now I have animal. Alright, and then I have mammal that inherits from animal, and then I have cat that inherits from mammal, and I have Persian cat that inherits from cat. Right, so I have right now 3 levels of inheritance. This is also another example of multi-level inheritance. So the difference between single inheritance and multi-level inheritance is that in single inheritance we have one base and one base class and one derived class. The derived class inherits from the base class. Here in multi-level inheritance we have uh, more depth of inheritance, right? So from base class, a derived class will be created. So the derived class will inherit from the base class. Then we will have level 2 derived class that will inherit from derived class. Then we will have level 3 derived class that will inherit from level 2 derived class, and so on. This can go on happening, right? We can have inheritance that can go on and on. Okay, so yeah, this is multi-level inheritance. All right, simple. Next, we are going to look at hierarchical inheritance. In hierarchical inheritance, what is going to happen? We are going to have a base class. For example, I have this animal class. Okay, so animal class is the base class. It does not inherit from anyone. Then I have mammal class and bird class. both mammal class and bird class inherits from animal class. Alright, so I have this animal, and from animal I have mammal, and from animal I have bird. Alright, so mammal inherits from animal, bird inherits from animal. This is known as hierarchical inheritance. Here I have one level of hierarchy. Alright, let us now look at another example where I have two levels of hierarchy. This is an example. I have once again the animal class. Then I have this mammal class that inherits from animal class. I have the bird class that inherits from animal class. Let us draw these three classes first. I have this animal class. Alright. Then from animal class I have this mammal class that inherits from the animal class. Right. So let me go ahead and draw the mammal class. And then I have this bird class that inherits from animal class. So let me go ahead and draw the bird class. Alright. Next, what do I have? I have this cat class and dog class. Alright. And both of them inherits from mammal class. So I have a cat class and I have a dog class, and both of them inherits from mammal class. Alright. And then I have a chicken class and a duck class. So chicken and duck, and both of them inherits from the bird class. Alright. So both of them inherits from the bird class. This is also a hierarchical inheritance. This looks like a tree, as you can see, rooted on this uh, base class animal. Alright. So animal is the base. This is the base of all these classes, and from animal I have directly derived two classes. Those are mammal and bird, and then from mammal I have derived cat and dog, and from bird I have derived chicken and duck. Alright, so this is a hierarchical inheritance with two levels of hierarchy. Alright, and this can go on. So from cat I can derive Persian cat, Indian cat. Dog I can derive like the different breed of dog. Chicken maybe I can derive Sonali, RIR, duck, Indian duck, Peking duck. Alright, so this can go on happen. Okay. So yeah, this is what I have. This is hierarchical inheritance. Alright, it looks like a tree. It is acyclic. There is no cycle in this. Alright, so you will know what is tree. You maybe know a little bit about tree. This looks like a tree. This is the root of the tree animal, and then we have all these branches and so on. Okay. So this is hierarchical inheritance. Another simple type of inheritance. So up till now we have seen three different types of inheritance. Alright, that we did not discuss in details. These are the three: single inheritance, multi-level inheritance, hierarchical inheritance. So these are, out of these five different types, these are three types. I'm not going to explain this in more details. We have already seen variation of these three types of inheritance in our previous classes. Alright, so these three types does not uh, deserve merit any more discussion. Right? But still, if you have doubt, you can of course reach out and contact me. Okay. Next, we are going to look at the fourth type of inheritance. It is called multiple inheritance. This is something new that we are going to learn right now. I have two classes, spider class and man class. Alright, none of this derives from any other class. So these are spider class and man class. Now what is interesting, I am going to create a new class. This is Spider-Man. Okay, I have a new class, and unlike before, up to this point we have seen three different types of inheritance. In all of these three different type of inheritance, each class, if it inherited from some other class, it inherited from only one class, right? All of this: cat inherited from mammal, dog inherited from mammal, chicken from bird, duck from bird, bird from animal. All right, so all of this inherited from only one class. So all these classes had only one parent. All right, unlike here in multiple inheritance, I am going to create this class Spider-Man Alright, I had these two different classes, one is spider, one is man, and I'm going to inherit from both of these classes. Alright, so Spider-Man class is going to have two different parents. One is this spider class and one is this man class. Alright, and this is the syntax to do multiple inheritance. So spider class I'm going to inherit from spider class. I'm going to inherit from man class. What is the mode of inheritance? What is the inheritance access control? I have to specify for each of the class that I'm inheriting from. Say spider, I want the access mode to be public. So I will write public spider. So man, I want the access mode to be private. So I will write private man. Okay. So this is how I can inherit from multiple parents in order to create this derived class. This kind of inheritance is called multiple inheritance. As you can see, this is the syntax. Alright. Uh, you will write class and name like before. Previously what we did, we wrote the access inheritance access control and the class from which we were deriving. This stays the same. Alright, this part stays the same. And now what I will do, I will keep on writing this separated by comma. Okay, I have this comma over here, and each of the class that I want to uh, derive from, okay, each of the class that I want to inherit, I will write the class name uh, after the inheritance access control mode. Alright, so public, private, protected, whatever way I want to inherit. We talked about this, the way in which we can inherit, we talked about this in the last class. Alright, so this is what we have. This Spider-Man has two parents. We can have different classes that can have more than two parents. So I can inherit from multiple different classes. This should not be a very difficult concept to understand. The previous three types should be very easy. We have already seen them in different forms in different classes up till now. Alright, this is something new that we are looking at, but this also should not be a difficult concept to grasp. Alright, so Spider-Man, we have this class called Spider-Man that inherits from two different classes. Alright, up till now we have seen classes inheriting from one different class, one class. Now we are looking at class that inherits from multiple classes. Alright, so this is what we have. Now let us go ahead and look at multiple inheritance at a little more depth. Okay, the what is multiple inheritance? Once again, multiple inheritance is when one class derives from multiple classes. Now don't confuse between multi-level inheritance and multiple inheritance. Multi-level inheritance is where we have different levels of inheritance, like mammal inherits from animal, cat inherits from mammal. Alright, so this is multi-level inheritance with two different level. Then we can have, say, Persian cat inherits from cat. That would be multiple level inheritance with three different level. Alright, so yeah, that is what we have. That is multi-level. What is multiple inheritance? Multiple inheritance is when one class inherits from two different classes. Alright. Alright. So let us look at this example. I have this class spider that has this attribute which is public as name, spider name, and then I have this class man which has this attribute m name. So man name, the name of the man. Alright. So I'm going to man has this attribute m name, spider has this attribute s name, and then I am creating this Spider-Man class which inherits from spider and man. Alright, so multiple inheritance. My Spider-Man class inherits from multiple classes, two different classes in this case. It can be, depending on my application, it can be from more than two different classes. Alright, so this Spider-Man class has a constructor. Alright, you can see this over here. Okay, this constructor takes two different string s and m. Okay, spider s for spider, m for man, and it assigns s name to s and m name to m. So what is happening? I have this spider class and I have this man class. Spider has s name Okay, man has m name, and so when I inherit from these two different classes, all right, in Spider-Man, then what is going to happen is these two attributes, all right, both of them will be inherited in this Spider-Man class. All right, I do not need to declare s name and m name explicitly in Spider-Man. They are going to automatically come from these two different classes from which I am inheriting. So s name is going to be there and m name is going to be there. All right, so yeah, then what do I do in the constructor? I set s name into the first parameter that is passed. I set m name into the second parameter that I pass. Now if say in my main function I have to use this Spider-Man class, what I'm going to do, I'm going to Spider-Man, so object s1. Okay, and if I want to create this, I will say radioactive spider and then say Peter. Okay, this is how I create a object. I call the constructor of the object. I can also do this in this way. I can create in heap as well. So Spider-Man s2. This will be a pointer, and I will write new Spider-Man. I will write radioactive spider and say the name of the person who is Spider-Man. Say Miles Morales. So Miles Morales, those of you who have seen this animated Into the Spider-Verse will know Miles Morales. All right. So that is what it is. We can create on stack, we can create on heap this Spider-Man, and this is how I initialize it. Very simple. Okay. So what will this do? This will be array as. So this will be set to array as. This will be set to uh, Miles Morales or Peter, whatever, depending on the uh, parameter. All right. Uh, Now next, when I have to print, say in my uh, main function, this is my main function. All right. Say I want to print the name of the person. Okay. So what I am going to do is I am going to write say s1 the m name. Right. So m name holds the name of the person, and this is what I am going to do. I am going to print the name of the person. So far so good. I can do that. All right. So I hope you don't have any problem understanding anything up to this point. Okay. So yeah, very easy code. Uh, just take a look at the code, execute it. It should be very easy to understand. All right. So let's go and look at something that is not as easy to understand. Okay, I have the same thing once again. I have spider class, I have man class, I have this public attribute to hold the name of the spider, the public attribute to hold the name of the man, and then I have this Spider-Man class that inherits from spider and man, and I have this constructor that takes the name of the spider and the name of the man, two parameter. I want to assign uh, this name to spider and this name to man. All right, so let us discuss this a bit further. I have spider class, I have man class. This has an attribute called name, this has an attribute called name. I inherit from both of them. I have this class called spider-man. Okay, so I'm going to inherit something called name. Okay, now a question is, where is this name coming from? Is this name coming from spider or is this name coming from man? Alright, so I have a bit of ambiguity. Alright, ambiguity or being ambiguous means this. If my friend calls me and tells me, where are you? Asks me, where are you? And I tell him, I'm in a restaurant. Alright, and that is going to be ambiguous, right? because in my town probably there are going to be multiple restaurants, and if I tell my friend that I'm in a restaurant, my friend is not going to know which restaurant I'm in. So he does not understand specifically, he does not understand exactly where I am. Okay, so there is vagueness in what I'm saying. Okay, this is called ambiguity. So in my Spider-Man class, when I write name, okay, say in this is my constructor and I want to say uh, this S. Okay, this should be the name of the spider. So I write name equal to S. Okay, this is going to be ambiguous. Alright, as soon as I write this line and I try to compile this program, I will get this error saying that the name is ambiguous. Alright, so with more messages. So see, GCC compiler, C++ compiler is very good in the sense that it exactly tells you what is the error. You just have to read the error message and you can very easily rectify the error, right? So you don't even need to do anything. All right. However, here I have this problem that I am unable to determine what should be name. Okay, so what do I do? I have to resolve this issue. I want to set this name to S and I want to set this name to M. Okay, so now I am going to use this scope resolution operator. Do you remember what is the scope resolution operator? It is double colon. Alright, we did this at the very beginning of the course. Now let us go ahead and use the scope resolution operator. In the constructor, I am going to write as I am trying to say into the name data attribute that is in spider, right? The name data attribute that is in the spider class. So I am going to write spider scope resolution operator name is equal to S. Okay, now there is no more ambiguity. What is this name? I am telling it exactly that this is the name that is coming from spider. Alright, what is the other name? There is going to be another name that comes from man. So man name is equal to M. So now I have removed the ambiguity. There is no more ambiguity. What is this name? This is the name that is there in my animal class. Alright, sorry, spider class. So this is the name that I am talking about in this line. What is the name in this line? What is this name? This is the name that is there in my man class. So this is this data attribute. Alright, there is no more ambiguity in this line. So I have removed the ambiguity. Alright, and how did I remove the ambiguity? Where did the ambiguity come from? The ambiguity came because we are inheriting from multiple classes. Alright, so these two different classes had the data attribute that had the same name. Okay, name. So I am inheriting from two different classes having the same variable name, alright, same data attribute name. Now when I inherit and I refer to this directly, right? So here I was able to refer directly. I was able to write s1.mname. Okay, and there was no problem. I was able to print this because mname is only here. There is no ambiguity. Okay, there is no mname in any other place in this class, Spider-Man class. Right, but here in Spider-Man class, in this example, I have name, and this name is coming from two different places, spider and man. So there is this ambiguity. So in my main program, alright. So this is what I do in uh, the constructor to resolve the ambiguity. Similarly, in my main program, if I have to do cout, say this is my main program. If I have to access this name, okay, so say my object is s1. So let me create Spider-Man s1 radio active spider Peter Parker. Alright, so this is how I created this object S1. Now I want to print the name of the person. Alright, I want to print Peter Parker. So I will write S1 dot name. Is this enough? Now I have once again I have the same problem. When I write S1 dot name, okay, what is this name? Is this the name that is coming from the spider class? Is this the name that is coming from the man class? Alright, so I am inheriting this name data attribute both from spider class and man class. Now when I want to print S1 dot name, what is this data attribute coming from? Is it coming from spider or is it coming from man? So I have this confusion. I have to remove this confusion. I had this confusion here when I was creating the constructor. Okay, how did I remove the confusion in constructor? I removed the confusion by using the scope resolution operator and the name of the class from which I am inheriting. For example, here I am saying that the name data attribute that I am using is coming from the spider class. Here I am saying that the name data attribute that I am using is coming from the man class. Alright, in the second line. Similarly, here also I have to remove the ambiguity. Alright, S1 dot name is ambiguous. Man data attribute is coming from two different places. So I have to remove the ambiguity. I do the same thing. I write S1, then I write the name of the class from which this data attribute is coming. Say I want to print the name of the person, Peter Parker. I will write S1 dot. Where is the name of the person coming from? It is there in my man class. So I will write man. Alright. Then I will write the scope resolution operator. And then I am going to write the name of the data attribute, that is name. Fine. Now this line, when I execute this line, this is going to print out Peter Parker into my standard output. Alright. So I no longer have any ambiguity in my code. Alright. So the ambiguity that was there, I did not know whether this name data attribute is coming from spider or man, is resolved. Now I know that this name data attribute is the attribute that is coming from man. Alright. So say I want to print radioactive spider, the name of the spider, instead of man I am going to write spider over here. Alright, and that will mean that this name that I am trying to print over here, this is coming from this class spider. Okay, good. So I hope you understood this scope resolution. Alright, I hope you understood the problem first. The problem was that if I am inheriting from multiple classes, alright, then I may have this two different classes. We may have attributes that have the same name and same type also. Here both of them are string with the attribute name. Alright, so when I inherit from these two different classes, I have this ambiguity, and this is how I resolve the ambiguity. Good. Exactly the same problem may arise with method name as well. So I have this spider class, I have this man class. Like before, I have this spider-man class that inherits both from spider and man class, and both this spider and man class have this print name method. Once again, both of them return void, both of them not taking any parameter, so there is ambiguity. Alright, now in my spider-man class I have inherited the print name from spider class, I have inherited the print name from man class. I have two different versions of print name. I have over here created this spider-man object. Alright, and then I am calling this as.print name. This is going to be problematic. Why is this problematic? Because when I use this spider-man object to call this print name method, alright, then I do not know which of these two different print names should I actually call. Alright, so there are two different print names. I don't know which one to call. There is ambiguity. So I have to resolve this ambiguity, and I am going to use, like before, the print resolution operator. How do I use it? I will write object name. Alright, then dot followed by scope, that is where is this name coming from, which class is this name coming from, is it coming from spider, is it coming from man. Okay, then I will write the scope resolution operator, this is 2 semicolon, and then I will write the function name, not function name, this could very well be uh, uh, attribute name. Okay, so I am going to write a property, either function or either method or attribute. So this is what we did in the last example as well, right? I wrote object name dot scope, scope resolution operator, and attribute name. Okay, the same thing. Remember this syntax. Okay, there is syntax. There is nothing to understand. Syntax you have to remember. All right. There is no reason why this is like this. This could have been anything else. This is something that the inventor of C++ decided. We have to remember this. Right. Now I cannot execute this line. Let me remove this. What can I do? This S is the object. Okay. And I want to say execute this function print name that is there in my spider class. So I am going to write object name first, right? First I have to write object name, so I'm going to write the name of the object as, then I have to write a dot, I have done that, then I have to write the scope, where is the function, where is the method that I want to execute, it is in spider, so I'm going to write spider. Alright, then I have to give the scope resolution operator, let me put that, and finally I have to write the method name that I want to call. Here it is the, what is the method name? Print name. So I'm calling print name. Okay. Now I no longer have any ambiguity. When I write this line, it means that this is the method that has to be called. Okay. Now in case I want to call this method, what am I going to do? I'm going to write s dot man followed by scope resolution operator and followed by the name of the method. If I write this line, then this is the method that will be executed. Alright. Now once again, like before, we had ambiguity. Previously, we had ambiguity in the sense that there were 2 different classes from which I was inheriting, and both of these classes had attributes that had the same name. Now once again, I am inheriting from 2 different classes. Both of these have the same method name, and this is how I am doing the scope resolution. I am removing the ambiguity. Alright, so yeah, this is what we have. Now, yeah, I hope there is no more confusion in this. These are not very difficult concepts. Right? So multiple inheritance, what is once again, what is multiple inheritance? Multiple inheritance is this kind of inheritance where I have a class that inherits from different classes. Alright, so this is one problem that may happen in multiple inheritance. What is this problem? Ambiguity. Okay, problem number 1. So when I say problem number 1, you may have guessed there are going to be more than one problem. Okay, let us look at another problem. What is here? I have this class called animal. Okay, now this animal class is there. Then I have this class called spider that inherits from animal. I have this class called man that inherits from animal. So I have spider, then inherits from animal, and I have man that inherits from animal. Alright, let's do this inheritance graph. Okay, and then I have Spider-Man, and I am inheriting from 3 different classes: animal, spider, and man. Okay, so Spider-Man inherits from spider, Spider-Man inherits from man, and Spider-Man inherits from animal. Okay, there is a problem. I'm going to get a warning saying direct base animal inaccessible in Spider-Man due to ambiguity. All right. So what does that mean? That means this animal is there in my spider class. All right. The animal is there in my man class. I cannot directly use this animal in my Spider-Man class. Okay. This animal I will not be able to resolve. Where is this animal coming from? Is it coming from spider class? Is it coming from man class? Or is it coming directly? I am not allowed to use animal directly. I am getting this warning. Okay, I can still execute this program. Alright, but I will not get. I may have inconsistent output if I do this. Alright, so I'm not going to do this. Very simple. I'm not going to do this. Alright. Now this is a problem. This is a famous problem in object-oriented programming. This is called diamond problem. Okay, so this looks like a diamond. I've never seen a diamond look like this in real life, but then this looks like a diamond that is there in cards. Okay. So this is what I have. And what is my solution? My solution is don't use it. So I'm not going to use it. Let's move ahead. No need to talk about this if I cannot use it. Once again, I have the same type of inheritance classes. I have animal, I have spider, I have man. Okay, I have animal, I have spider, and I have man. Okay. Then in Spider-Man, what I'm doing, I'm inheriting from spider and man. So I have Spider-Man. Uh, Spider inherits from animal, fine. Man inherits from animal, fine. And Spider-Man inherits from spider and man. Alright. So now I don't have this anymore. This is not there. This is removed. Okay. That I had previously. This is not there. So that warning is not there. That problem is no longer there. Alright, fine. So I can create this Spider-Man object. I have created this Spider-Man object over here in my main program. Alright. And then what I want to do is I want to print this string. This animal class that is there. Alright. Uh, I want to print it directly from animal class. I know I can print from spider class. If I do this, the name of my object is s. So I will write s dot spider scope resolution, then name. So if I print this thing out, it will print radioactive. If instead of writing spider, if I wrote man, then this will print Peter Parker. Alright, but if I write this, see out as dot animal. Okay, I am inheriting from animal. Animal is there in my uh, class, Spider-Man class. Okay, this animal class is inherited in Spider-Man class. In animal class is inherited in spider, and spider is inherited in Spider-Man. Therefore, animal is through this spider class I am inheriting animal. Alright, that I know for sure. Animal is there in my spider class. That's fine. So I should be able to write s dot animal and then write name. Okay, and that should be printing this. I know I was able to print s dot man scope resolution name, that was printing Peter Parker. If I wrote s dot spider and scope resolution name, that was printing radioactive. Alright. Now, given the same kind of logic, if I print s dot animal scope resolution name, it should be printing generic animal, right? But this is the output that I get. This is not the output. I cannot even compile. This is the error that I get during compilation. Alright. Animal is ambiguous base of Spider-Man. So it is the same problem. Once again, we are looking at the diamond problem. Okay. Now this spider animal is coming through spider, animal is coming through man. All right, and when I say Spider-Man, I want to access the animal that is there in Spider-Man. All right, so S is the Spider-Man object. In S, uh, what is the scope animal and what is the variable name. So through Spider-Man, when I want to access the name of the animal, I do not know whether I have to use this route or I have to use this route. I am getting animal from two different places. I do not know which of these two animal do I use. Okay, once again we are looking at a variation of the problem that we just saw. It is the diamond problem. Okay, this is a big problem in object oriented programming. What are we looking at? We are looking at the diamond problem. Okay, this is a very real problem. Okay, and we are just looking at how this problem uh, gives rise to warning and error during compilation. Okay, and we try to understand what is the source of this error, why is this error coming, because of this ambiguity. uh, we try to understand why this ambiguity is coming, because multiple paths are there. Okay, if I ask you to say uh, come from Jorhat JC up to Borua Sariali, so you have this choice whether you go through the in front of Big Bazaar or whether you go through Gorali and Nirmal Sariali. Okay, so if I uh, ask you to come and I cannot know which path you are going to come from, right? So if I go ahead and try to meet you halfway, I'm going to have some problem. Okay, so yeah, that is my analogy, and this is what it is. This is the timer problem, and I hope you understood what is the problem, why is the problem there, and we are not going to talk very much about how to resolve this problem. I'm just going to show you the code that will resolve this problem, but then uh, we are not going to discuss that in depth in this class, right? But then what did other languages do? I mean, C++ is not the only object oriented language, right? There is this other language called Java. So we are going to look at the solution. If solution exists, we are going to look at that. But Java's technique is very simple. Java does not allow multiple inheritance. Alright, so yeah, this problem arises because we have multiple inheritance. If I remove multiple inheritance, there is this problem will cease to exist. So that's the technique that Java uses, and other object-oriented languages are there that uses this technique as well. Alright, but what is the technique in C++? C++ gives a solution to this. Alright, to the diamond problem. There is something called virtual inheritance. Alright, so if I write this keyword virtual when doing this inheritance, alright, here I did not have this keyword. This is the only change that I make in my program. I just add this keyword virtual here and the keyword virtual here. Alright, and then things are going to be good. If I write s.animal scope resolution name, this is going to print generic animal. If I write s.spider scope resolution name, that is going to print radioactive. If I write s.man scope resolution name, that is going to print Peter Parker. Alright, so this virtual inheritance allows us to handle this problem. Okay, the diamond problem. Now we are not going to talk about virtual inheritance anymore in this class. Okay, this is a topic for another class. I am showing you the syntax, but looking at the syntax is not sufficient. We have to look uh, this syntax. This is how you resolve this problem, right? You understood the problem. This is the solution to the problem. But just looking at the syntax of the solution is not enough. We have to know what is happening behind the scene. All right. So I'm going to leave this virtual inheritance for a different video. All right, and we are not going to talk about multiple inheritance anymore. Let us now talk about the final form of inheritance, that is hybrid inheritance. What is happening here? I have this class called animal that does not inherit from anyone. I have this class called man that inherits from animal, and I have this class called robot that does not inherit from anyone. All right, so man inherits from animal, robot does not inherit from anyone, animal does not inherit from anyone, and I have this class called robocop that inherits from man and robot, right? So this is my inheritance graph, and this kind of graph are called inheritance graph, not a uh, formal term, but it's a term that defines this graph very well. Okay, now if I look at this graph, I can see over here, if I look at this part of the graph, I see that there is multi-level inheritance, right? There are two levels of inheritance. Robocop inherits from man and man inherits from animal. All right. And if I look at this part, I see that there is multi-inheritance. Okay. So Robocop inherits both from man and robot. Okay. So if my inheritance graph has more than one of these other four type, okay, so if I can do this mix and match, those kind of inheritance is called hybrid inheritance. It is a hybrid of the other types. So I take this so these are the four types that we studied. Okay, so if I take two of this type and then combine them together, then two or more of this type and combine them together, what I will end up is the hybrid inheritance. Alright, so this is what I have, the final form of inheritance. Okay, so another easy inheritance technique. So the most uh, complicated, not complicated, but the most problematic, okay, type of inheritance is multiple inheritance. Why is this problematic? Because multiple inheritance can give rise to ambiguity. All right, we have seen that, and it can give rise to the diamond problem. We have seen that as well. Okay, so there are two problems, at least there are two problems that arises because of multiple inheritance. Now we saw how to remove ambiguity by using scope resolution, but then there are cases like in case of diamond problem where scope resolution itself is not enough. Despite using scope resolution, we may still have ambiguity. Okay, so what to do in that case? In that case, we use virtual inheritance. In virtual inheritance, actually what happens is our base class, that is in our example that would be uh, the animal class. There is going to be only one copy of animal class in Spider-Man class, right? So in diamond problem, what is there? There are two copies of animal. One is coming through spider class, one is coming through man class. So this animal is parent of both spider and man, and both spider and man are parents of Spider-Man. So this animal class is one copy of animal class is coming through spider in Spider-Man, and one copy of animal class is coming to this Spider-Man class through this man class. Alright, so virtual keyword removes this. There is not going to be two copies of animal, there will be only one copy of animal. Alright, so yeah, that is what I have. That problem is resolved in that manner in multiple inheritance by using virtual inheritance. Alright. And then we finally looked at hybrid inheritance, another type of inheritance, which is essentially a mixture of the other type. Okay, nothing to understand here. Okay, just a hybrid of the other two types, other four types. Okay, so yeah, this is where we are right now. Next, let us look at another thing that may happen when you have inheritance. Do you know what is a yo-yo? It's a toy. If it goes down and it comes up, it goes down and it comes up. What may happen is that your inheritance graph may grow so big. Okay, if you are not careful, it can grow so big that in order to understand your code, you will be looking something in here, then you will go up and look here, and then you will come back and look here, you will go up and look here, your eyes will move like a yo-yo. Okay, so this is the yo-yo problem that may happen in object oriented programming. The yo-yo problem is an anti-pattern that occurs when a programmer has to read and understand a program whose inheritance graph is so long and complicated that the programmer has to keep flipping between many different class definition. So the programmer has to go through all these different class definition, right, in order to follow the control of the flow of the program. What is the program doing? In order to understand that, you have to go up and down. All right, so this is the reason why it's called yo-yo. Often we get the feeling of riding a yo-yo when we try to understand one of these messages, one of this graph. Okay, this inheritance graph. Uh, we have to, our eyes goes up and down like it and yo-yo. So it's called a yo-yo problem. All right. So what is the solution to yo-yo problem? One solution is keep the inheritance graph as shallow as possible. Do not get a very this multi-level inheritance. Don't make it too high. Okay, keep it as shallow as possible. Have as less inheritance as possible. But the better solution is point number 2. Use composition instead of inheritance. All right. We will talk about this soon. Another problem with inheritance, apart from this yo-yo problem, is that inheritance is against encapsulation. What is encapsulation? Encapsulation says that man, okay, and robot. Let us look at this. I have two classes man. I have one class man and one class robot. Okay, and man has this method eat food, eat food. Robot has this class method charge batteries. All right. Now, Robocop is a class that inherits from man and it inherits from robot. So Robocop will inherit from man and Robocop will inherit from robot. Therefore, both these methods will be inherited by this Robocop. Robocop is going to contain both of these methods. All right. It is going to contain eat food and it is going to contain charge batteries. Now here is this problem with Robocop, this class called Robocop. What is encapsulation? Encapsulation means data and methods that act on this data that have similar kind of properties should be together as a unit. All right. Now man has similar kind of property. There will be data and attributes in this man class. Robot will have similar kind of property. There will be method and attributes regarding robot. Okay, so when I create Robocop, uh, I am ending up with a class that has methods related to man and related to robot. There are different kind of things that comes together. Okay, it is no longer one concept in one unit. Okay, now I have this one unit of code. I have this Robocop class that contains concept from this man class and concept from this robot class. My idea, the thing that we were aiming to do in object oriented, encapsulation, abstraction, these are very important aim behind object oriented programming, right? Object oriented programming, I said at the very beginning, is not going to give me any power. Okay, that I cannot create any software in C++ that I cannot create in C. Means whatever I can create in C++, I can create in C. Why do I use C++? Because my code, my management of code, writing of code, using of code is going to become easier. Okay, this Robocop is spaghetti, is khichdi. Okay, so I have things from different places. I have lots of different unrelated things in here. Okay, this beats the encapsulation philosophy that I have. Okay, moreover, what is inheritance? Inheritance is a easy relation. I don't want to dive too much into this, what this means. Robocop is a man. Okay, Robocop is a robot. This is what inheritance says. I don't want to dive into this. This is something that comes from UML diagram. Okay, so you will learn this in software design, software engineering. Okay, so we'll not go into this. But look at the code. Okay, look at what is happening. This is not something that I want. Okay, my encapsulation is defeated. Now I have this method in Robocop called wake up. This should be very easy to understand. This, when I call this wake up method, when this Robocop wakes up, he is going to eat food because he is a man, and he is going to charge his batteries because he is a robot. All right. So both these methods are called in this wake up method, and that is fine from C++ point of view. Okay, and you realize this is fine. I am not talking about syntax of C++. I am talking about this philosophy of encapsulation. This beats the philosophy of encapsulation. Okay, this program should be easy to understand. Uh, okay, and the thing is that in this program, I have two different classes, man and robot. Each of them are perfect. Both these two classes, man and robot, are perfect in the sense of encapsulation, that both of these are unit of code uh, that have data and methods that make sense together. Okay, but in Robocop, because of inheritance, what am I doing? These two different things that were there, I am pouring both of these and mixing them inside this Robocop. Okay, encapsulation suffers. Now I have code of two different concepts inside one single unit. Okay, now this is something I don't want to do. I don't want my encapsulation to suffer. So let's go ahead and remove that. Instead of Robocop is a man, instead of inheriting from man, what I'm going to do is this. Once again, I have this man class. Once again, I have this robot class. In Robocop, I am not going to use inheritance. I am not going to use inheritance. Okay, and this is not something uh, that matters only in this example. If I can, I will not use inheritance. Instead, what I will do, I will create complex object. Okay, what is a complex object? A complex object is an object like this that is made up of other objects. Okay, this object has other object. This has the man object, this has the robot object inside it, and this is a composition of object. So compose this object robocop by using other objects, right? So once again, this thing that I wanted to do, when I wake up, I want this robocop to eat food and charge batteries in complex objects using composition. How will I achieve that? This is what I do. I am not going to use inheritance. I am going to create a man object. I am going to create a robot object, and in my wake up method, I am going to call eat food using the man object. So I write m dot eat food. Alright, and then I am going to call the charge batteries of the robot object. So I am going to write r dot charge batteries. Okay, and by doing this, I am getting the exact same thing that I was doing before. Okay, but I am not making a khichdi of everything. Okay, I am not pouring everything that was in man inside this robocop class. I am not pouring everything that was in robot class inside this robocop class. I am not pouring everything in this robocop class. Instead, I am creating objects in my robocop class. Okay, the encapsulation does not suffer. All right, so this is what I have. This is how I can create complex object. This is how I can, inside my object, inside my class, I can create an object of a different class. Okay, now my class is made up of different objects. All right, and all of them are their own different encapsulated unit of code. Okay, say I want to make a car. My car is going to be made up of wheel. It's going to be uh, uh, steering, infotainment system, seats, say sunroof, and so on. Okay, now each of these will be a different object. I am not going to inherit from all these 100 different things that make up a car, or 1,000 different things that make up a car. I am going to create, if needed, 1,000 different object. Okay, maybe I will create them in heap memory, and when I don't need it, I will free them up from heap memory. I will delete from heap memory. Okay, that is something that I can do, that will allow me to do very good management of memory instead of pouring everything into a very big and bloated uh, class. Okay, instead of inheriting everything into a very big class, I will simply create objects, use it, and throw it out whenever needed in this complex object. All right, so this is what it is. This is a better way of writing object oriented code. Here we are looking at C++ code. By doing composition of object, we are creating objects that are made up of other objects. All right, instead of using inheritance. So inheritance has a few problems. We talked about this, uh, and this is a solution to many of this problem: composition of complex object. Now, the thing is, uh, this is a has a relation in terms of UML. You don't need to understand between is a and has a. Okay, just remember this. You will means if you have the links to this video at that point, when you study software engineering, you will read UML diagram. You will see in case of inheritance, if I do inheritance, it makes sense like this, right? Uh, a mammal is an animal. Okay, so if mammal is an animal, therefore in mammal I should inherit from animal. Okay, now car has steering wheel. Okay, car has a wheel. So here I should use composition. So composition is a has a relation, inheritance is a relation. Don't worry too much. We are those are software engineering things. Okay, we are doing object oriented programming over here. We are doing programming, not software engineering. Software engineering deals with design of software. We are more interested right now in writing code. whatever be the design. Alright, very soon we will be looking at design in the second phase, maybe after 6 7 hours, 6 hours of class. Okay, so this is what I have. This is composition of objects that are made up of different object. All right, now I am not saying inheritance is entirely bad. Okay, had inheritance been entirely bad, I would not be spending so much time and so many classes going through all these different things of inheritance. All of the concepts of inheritance that you have studied, all of them are necessary. At one point or another, you are going to see that inheritance is very useful in whatever task you are doing. Okay, but the thing that I wanted to point it out is that inheritance have problems. Okay, inheritance may not be the solution that you need. Okay, don't say there is a class, this Robocop class is something that I wanted to make. To make this Robocop class, I needed things that are there in man class, I needed things that are there in robot class. But just because I need things that are there in man and robot class does not mean that in my Robocop class I'm going to inherit from these two different classes. Alright. So just because I need things from an object in my class does not mean that I am going to inherit from that class. Yes, there are places where inheritance is going to be useful, where inheritance makes the most uh, normal choice. Okay, but not everywhere. So that's the point. So yeah, this is composition of complex objects or composition of objects. Okay, what is a complex object? A complex object is an object that is made up of other objects. For example, this Robocop object is made up of two different objects, M and R. M is the object of type man, R is the object of type robot. So that is what we have, and this is what complex object means. All right. So yeah, with this we have come to the end of this video. Okay, in this video we started off by talking about what are the different class in sorry type of inheritance. uh, there are 5 types of inheritance: single inheritance. Okay, multi-level inheritance. We saw multi-level inheritance with 2 level, 3 level. Then we looked at hierarchical inheritance with 1 level of hierarchy, 2 level of hierarchy. Then we looked at multiple inheritance. We looked at a use of multiple inheritance where I am creating uh, means inheriting from two different classes and using them normally without any problem. This is fine. This example does not have any problem, but then this example has a problem. The problem is that there is ambiguity in data attribute name. Then we talked about how to use class name and scope resolution operator in order to remove this ambiguity. Same kind of problem was in this example as well. Here, instead of data attribute, I had ambiguity in method name. Okay, so in the same way in which we remove the ambiguity in attribute resolution, in the same way we remove the ambiguity that is in here. All right. Then we looked at another problem. This is the diamond problem. So we looked at another version of diamond problem in this slide. So diamond problem we said arises because there is ambiguity, and why is this ambiguity coming from? This ambiguity comes because of multiple inheritance, and for that reason one way to remove diamond problem that Java uses is to completely disallow multiple inheritance. Okay. Now, in C++, there is something called virtual inheritance that is used to resolve this problem. Okay, so yeah, this is what we have. I'm not going to say this is good, this is bad, Java is bad, C++ is good because there is virtual inheritance. It does not really matter. Okay, you can create means there are always techniques to do one thing in more than one different way. Okay, there are multiple different ways in which you can do a thing. So just because virtual keyword is there in C++ does not mean, and it is not there in Java does not mean C++ is better than Java. There are lots of places where Java makes more sense. Okay, you are not going to study Java. Uh, Maybe in some other video I will talk about Java a little bit. Then we looked at hybrid inheritance, which is a mixture of inheritance of the other four types. So if I have an inheritance graph that has features of the other four types of inheritance, that is going to be called hybrid inheritance. Then we looked at a problem called yo-yo problem, which happens if I have very big uh, inheritance graph. Okay, then I will have to read a lot somewhere else, something in somewhere, then something in somewhere else. So this beats the purpose of object oriented, right? Object oriented, we are not supposed to look at lots of things simultaneously. Okay, each part, each class should be self-contained. Okay, when I am working in a class, I should only concentrate on that class. I should not be looking at 100 different classes simultaneously. I should not be bothered about what is happening in other classes. All right, so if I have to do this, if I have to keep track of 10 different classes simultaneously, then what is the point of using object oriented? What, yeah. Now, this case that I made, inheritance uh, also removes encapsulation, right? So if I use inheritance, I am taking everything from a class, I am taking it into another class, I am inheriting everything from this parent class in the child class. So what is the point of encapsulating everything in the parent class if I take everything out and put it in the child class, right? So everything should be self-contained. This thing that is inside parent class should not be there inside child class. All right, but this happens in inheritance. So inheritance harms encapsulation of a program, right? And then we looked at a very good technique where instead of using inheritance, we are using composition of object. More specifically, we are creating complex object. Okay, so this was the content of today's video. I hope you understood everything. If not, you can reach out to me through WhatsApp, mail, or by writing your doubts in the comment section below. Thank you for watching this video and see you in the next video.